So last week we started using Lucidchart to flowchart stuff. We will do a little bit more of that today, I am sure. Also, we're going to talk about creating hierarchy charts, but we're not going to talk much about it. I'm not going to draw any. Just make sure that you know enough about them in order to answer any question on MindTap about them, and then we'll go from there. So what is a hierarchy chart? Just like you go to a business and you see that there's a CEO, the CFO, and accounting, this and that and the other, right? You know what those look like. Flow charts of how people their ranking in an organization. It shows the overall picture of how modules are related to each other. It tells you which modules exist within a program and which modules call others. So a specific module may be called from several locations within a program. Like this. We could have a main program, and it's got a housekeeping module, and it's got a detail module, and it's got an end of job module. Then we decided to break it down further. The main program's got a housekeeping module, which calls something called get order. The main program's got a detail loop, which has got a process order and a get order function. Looks like they both call something called get order. That's okay. The process loop is just showing the functionality involved. And then there's something called end of job, which calls the display summaries function. Now, process order has got several modules that it calls. Check inventory, check credit, whatever. Right? So you get the idea. There's pieces of code, and then they get broken up into modules, and then those modules can call other modules, and the hierarchy chart just shows which modules can be called by which other modules. So features of good program design. You use comments where appropriate, or pound signs followed by the sentences to describe what our program is doing or to make notes of what it's doing to clarify the logic. Please choose your identifiers, your variable names, and your function names carefully. Strive to design clear statements within your programs and modules. All right. Write clear prompts and echo input. I don't remember hitting anything about that, but what does echo input mean? It means, like if you had something like this. Maybe we mentioned it. Right. But, what is the height of the blah, blah, blah? And you type in something. And you say, what is the age? Right. Okay. So what is name? We type in somebody's name. Joe Namath. What is the height of Joe Namath? He's 6'8". What is the age? Well, he's pretty old now. So if he's still alive, he's 78. Okay. And then towards the end of the program, we can echo that input. Patient name, Joe Namath. Height, 6'8". Age, 78. Something like that. Right? Just so that now that I've typed all this stuff in, I can eyeball it and make sure I got it right. Just like before you place your Amazon order, you get a chance to verify that everything's good, that you've chosen the correct credit card, that you've chosen the shipping method that you want, whatever. That's called echoing input. Echoing input is when you display what the user typed in as part of the output. So that's our example. What is the name? What is the height of? What is the age? And then we echo the input. As part of something else, right? Who knows what else we may be calculating here, but we're also going to display the person's name and their height and their age just to make sure that the user knows that they typed it correctly or that they can go back and edit it if they need to. And so then we have writing a clear prompt. Tell the user what they need to enter. Don't just put a question mark on the screen and expect them to know what to type. Right? So the prompt is a message that's displayed on the monitor asking the user for the response. What is your name? What is your height? What is your age? What is the weight in kilograms? And so prompts are used both in command line and graphical user interface programs, right? You have places where it'll ask a question on a little window and you type in something. And then, like, as we mentioned, echoing the input is when you read back the input. When you print it back out to let the user review it. So program comments, we know what those are. We've been using them. That's the written explanation of the programming statement. We just prefix them with a hash. They're not part of the program logic. You can take them all out and the program still runs, but it serves as documentation for the program. It's like writing an outline, you know, for your essay, but you get to leave the outline as part of the essay when you submit it, so that when you come back and rewrite it later, you see what your original intention was. So the syntax does differ among programming languages. Some languages use a // rather than a hash in order to mark the comments. And so we've looked at flowcharts. Flowcharts, it's a good idea to add an annotation symbol to hold information that expands on what is stored within another flowchart symbol. Well, I sure hope they give an example of that, because I'm not going to fire up Lucidchart. I'm going to show you just that. We'll get back to it. So program comments. When you declare a variable, you can give an example of what it is. Square feet is an estimate provided by the seller of the property. Price per foot. Price per foot is determined by current market conditions. Lot premium. Lot premium depends on amenities such as whether the lot is waterfront. Okay, now these are actually pretty long comments, but they certainly would make the program more clear to read. So here's an annotation symbol. And I really don't have us do this in our flowcharts. But if you need to put a comment, you can put a comment out to the side of the flowchart. Note, rate is expected to increase. All right. Program assures all employees make the same standard hourly rate. Or assumes. Okay. So choosing our variable names. In general, your data are nouns. So give a variable or consonant a name that's a noun. It represents a thing, the speed, the age, the height, the weight, the number of orders. And then you give the function names, the module names, verbs, because it performs an action. Dot forward means to go forward. Dot back, you know, dot left, dot right. Really, those aren't verbs. Those aren't the best example. But, you know, calculate interest. That's a verb, right? Divide by. That's a verb. So we should use meaningful names because it helps the program be self-documenting. You have to write fewer comments if your variable names are good. Use pronounceable names. All right, I like that. Be judicious in your use of abbreviations. Don't overly abbreviate. And avoid digits in a name. All right. Sometimes you'll see me use digits just because I'm doing like X1, X2, and X3, but rarely will I otherwise use digits because it doesn't make much sense to be throwing them in there if it makes the code more difficult to understand and read. So use the system that your language allows to separate words into long multi-word variable names. Well, what does that mean? That means if you need patient height in inches, you know, you can say patient height in inches. That's one way of doing it. Or patient underscore height underscore in underscore inches. We just can't leave spaces out in our language. And some languages let you use hyphens in the middle of your variable names, but ours doesn't. So those are really our two choices. One is to do this thing where we mix in the capitals and the lowercase, which is known as camel case. And then we have this one, which somebody came up with an absurd name of snake case because it's got these underscores in it. Anyways, you can use underscores or you can use mixed uppercase and lowercase. It's just harder to read if it's a long thing like this with no visual way to break it up. Patient 8 and just, it takes me a second, right? It takes me a little while to actually figure out, you know, what it's saying. Whereas if it had those underscores in it, it's far more readable. Or if, so you just pick a styling and go with it. Underscores are a little bit more old school. I think I've said that. Doing the mixed upper and lowercase is a little bit more modern. It's the way that most people are taught nowadays. So in general, if we have a constant, we should name it with all uppercase letters. So if we have some variable that says minimum age, we're not going to let anybody into our system if their age is less than 0. That's stupid, but right. Minimum underscore age equals 0. All right, so that's how we named it. Just because constants should be uppercased and underscored. That's a silly way of putting it, right? That's not great grammar. But anyways, put them in uppercase, put them in underscores, and we'll be good. And programmers can create a list of all variables called a data dictionary. Now for our itty-bitty little programs, we're not going to be doing that, right? But we could go through all of our code, you know, and create a document. We could copy and paste, you know, into the Word document every variable we use and write a description of what its meaning is. I've really never done that in all my years as a professional programmer, but we certainly can. Theoretically, we certainly could. So that's what a data dictionary is. It's just a list of all the variables. Avoid confusing line breaks. Well, I don't know how a line break can be confusing, but it sounds like good advice. And we can use temporary variables to clarify long statements. So if you have some equation that looks like this, I don't even know if I can give a good example of it. A temporary variable is when you calculate something just so that you can use it in another statement that's coming up. Like, if your formula is this, V is equal to nRT divided by P, right? And then we happen to know these values. We know that N is going to be 10, and we know that R is going to be 0.821. You don't need to even know what this is. And we know that the temperature is going to be 300, and we know that we're going to... Anyways, it'd be a better idea to calculate some of these things in advance, right? So if we can calculate N, because N is actually supposed to be a certain number divided by another number, then we could do that. Right, because if N was actually supposed to be, you know, 100,000 divided by 9.0 e to the 23, it'd be a lot better to say N is equal to 1,000 divided by 9.0 e to the 23, and then use that in our equation, right? And then if the pressure was something that needed to be expressed by taking a number and then multiplying it by some factor, it'd be a lot better to go ahead and express that as a temporary variable beforehand. Really hope y'all aren't typing this as I just keep recklessly editing it. Okay, there we go. Right, so we're creating temporary variables. The only reason we're using these variables is, or making these variables, is so that we can then come back and use them in another statement. They weren't absolutely necessary, right? I could have just plugged all the numbers in that formula right there. I don't know if that's the greatest example. Next time we use a temporary variable, I'll point it out. The temporary variable is a variable that is created just so it can hold a value to be used in a following statement. So in the above example, we created N and P just to shorten the last statement and make it more readable. So avoiding confusing line breaks. Most modern programming languages are freeform. Make sure your meaning is clear. Do not combine multiple statements in one line. We technically can do that. In this language, if we do this, x equals input, semicolon, x equals float, parentheses x, semicolon, y equals x times 2. That works. That's a valid couple of programming statements that would not give a syntax error. But don't do that. Put each one on its own line. Yeah, sure. So don't do that. Instead, put each statement on its own line and use blank lines to make your program more readable. Dang, is it cold in here. I say that every time.
Can you change the temperature, or is that like set already?
I don't have any control over it. I wish I did. I might be able to ask somebody to have the temperature changed. I'll stick my head in the office next door and ask over the break. So a temporary variable is known as a work variable. Not used for input or output. It's a working variable that we use during the program's execution. We can hold a series of temporary variables to hold intermediate results. So for example, if later on we're going to use this in our formula, then we may as well calculate it and store it in a variable called sales commission. Or wait, no, this is the long formula, but we've decided to break it up with some temporary variables. Right? This thing's got 4 different factors in it. It's kind of hard to read. So instead, we calculate base property price, we calculate total sales price, and then we calculate our sales commission based on the total sales price and the commission rate. Now, it could be that you think that's easier to read than all that. And I couldn't change your mind about it, but I could say that if we had it broken up like this, then we could print out these factors as well, right? If we could not figure out why the sales commission was being printed out incorrectly, then we could add some debug print statements to print out the base property price and the total sales price. So in a way, we've been doing this all along. In a way, we've been using temporary variables. What do I mean by that? Because we have done things like this, right? Pounds equals input, right? And then we took pounds equals float of pounds, and then we use that in some expression. kg is equal to pounds divided by 2.2, whatever. We could have written it like this, and it would be stupid, but we could have. We could have said kg is equal to float parentheses input parentheses divided by 2.2. That does work. If I copied and I pasted this line of code, especially if we put, you know, pounds equals right here, right? To let them know what they were supposed to type. That actually would work. I could go and I could copy that into the idle shell. So 100 pounds is, well, I didn't print it out, right, but then we could have printed it out. So anyways, this is an example of using temporary variables. we used a variable called pounds in order to make this expression a lot easier to read, to make the code a lot more maintainable. Because if you had to look at this for long, your eyes would cross, especially if it was a longer expression than that, right? I mean, you know, you can write something that goes off the edge of the screen if it's got too many, you know, pieces of data it's supposed to manipulate. So that up there, the above is a lot easier to read than the below. So a prompt is a message displayed on the monitor. Echoing input is when you repeat the input back to the user. Kind of like just saying, you know, somebody asks you to go to the store and get eggs and milk. You say, okay, you want me to get eggs and milk. You might say, you know, anything else, right? We're echoing the input to make sure that the user knows exactly what they typed in. Just like if you're filling in an online purchase order, you usually get the chance to, you know, is this information correct before it finally saves it. The beginning of a program that accepts a name and a balance as input. So I think I've already said that we don't have to do a declarations block. I'm never going to count you wrong if you do, since the book gives a demonstration of it. If you do, it goes below the start oval. And then the rest of the program can use those variables. Output, please enter the customer's name. Input, the name. Output, please enter the balance due. Input the balance. So we're just using the variables that were created up in the declarations. Notice the space before the question mark that asks the user for a balance. The space will appear between for and the last name. Well, that's true enough. If we did this, print the answer is, if it was one of those languages that didn't put a space between everything already, okay, fine. Print parentheses, the answer is, end quote, plus kg. Now we've been using commas between our print statement to fill in the parameters of our print statement because that automatically puts spaces in. A plus sign just happens to not, but everything has to be of the correct data type to get it. So I'm going to a lot of trouble just to give the example of here. We printed something out and it didn't have a space in it. And it sure would have been much nicer to have a space in it. But we will see things like that if we use the input statement, right? X is equal to input, question mark, name is, or what is your name? Something like that. If you think it looks good to have them type right next to that question mark, fine, that's your choice. I would have put a space here. As a matter of fact, I probably would have put a couple of spaces and a greater than sign. You've seen me do that. More like this, right? Just to let them know where they're supposed to type it. Make it real clear. Every program you write will be better if you plan before you code, if you maintain the habit of first drawing the flowcharts or writing pseudocode, if you desk check your program logic on paper. Okay, I'll whisper something. Nobody does that. Think carefully about the variable and module names you use, and design your program statements to be easy to read and use. So our summary. Programs contain literals. What are literals? Should ask this deal. But a literal are the numbers and strings that appear directly in the code. Like this. X is equal to 2 times Y. 2 is a literal. It's literally typed into the code. If the formula is wrong, you have to edit the code in order to correct it. This is what's known as a string literal. Right, so if we do state is equal to OK, right, OK is the literal. It's a string literal. While as this was a numeric literal. Kind of watch how you're writing your code and to see if any of these are so-called magic numbers or to see if any of them should be turned into a constant. So for example, if we have a formula that looks like this, G is equal to 6.022 e to the 23 n divided by 6.022 e to the 23. That's kind of a mysterious number. We could put, you know, some law out here, Avogadro's law, but we might think that that number, if we're going to use it over and over and over, should be turned into a constant. Maybe 6.022 e to the 23 should be a constant. In which case, we would declare that up at the top of the program. In which case, do this. In which case, do this. Right? Avogadro's number equals 6.022 e to the 23, and then G is equal to n divided by 6.022. Oh wait, G divide, what? G, I can't type today. G is, I haven't had enough coffee. G is equal to n divided by Avogadro's number. All right, then we have half a clue. We could look up what an Avogadro number is. I misabbreviated that. Who knows what the abbreviation is really supposed to be. But the idea is that if we're going to use this number over and over in our program, we ought to make it a constant so that if it needs to change, we only have to change it in one place. And to make it a constant, in this language, we just put uppercase letters and we pretend it's a constant. In the other languages, once you declare something as a constant, if you tried to change its value, like if you tried to add 1 to it, don't type this because I'm going to delete it. If we try to add 1 to it, that would be a syntax error because we're not allowed to change constants. In this language, we just kind of agree to ourselves. If it's in all caps, we're not gonna try to have our program modify that value. So, like constants, conversion factor. The conversion factor for kilograms, I said that it was 2.2. That's not very precise. So I typed in a formula that said, you know, pounds divided by 2.2. That definitely was not precise. We probably could have declared this as a constant and then use that later, right? And then we could have looked up the better version of the formula, right? Kilogram conversion equals 2.2, whatever, and then pounds, or then kg equals pounds divided by the kilogram conversion. Now in my assignments, when I give you a formula and I say, you know, centimeters is equal to inches divided by 2.54, I don't make you then go and define 2.54 as a constant before you can use it, all right? You're just kind of trusting that my formulas are right, and if it doesn't work right, I'm certainly not going to grade you wrong because I'm the one who gave you the formula. But if you're writing your own code, if you find yourself using a number over and over and over, or if it's a conversion ratio, or if it's something that should not change while the program is running, right? If for some reason the value of the kilogram conversion changed halfway through the program, then some of the answers are going to differ than other parts of the answers, right? You know, it's the speed of light, if we're writing some astronomy program, should not change. It's a fixed constant in the universe. You know, the value of pi should not change. You know, the value of whatever numerical constant we like. I have no idea anymore. It's been a couple of decades since I learned what E meant. But, you know, E is a constant, and its value should not change halfway through the program. So what we should do is, if we have something like this, we should add comments to our code explaining what this is. Avogadro's number, and then calculate the number of grams. And what is N? N was supposed to be the number of molecules in the substance. You don't care. I don't really care. But what if I type 2? Okay. And this is the kilogram to pound kilo to pound conversion. But I will make a parenthetical comment that that is not, 2.2 is not precise enough. We should look it up. It's a loose approximation. I can go and Google it, right? So why not? 1 kilogram in pounds, or wait, yeah, 1 kilogram in pounds. If I look it up, it's actually that number. So I should use that in my formula instead. We are about done with this chapter. Indeed we are. Nope. Arithmetic follows the rules of precedence, meaning multiplication and addition happen before addition and subtraction. That'll be an exam question. So if it says arrange these in order of precedence, and your choices are addition, multiplication, and let's say exponents was thrown in there, and then parentheses. Well, then what first is if we can somehow remember PEMDAS is that parentheses are on top. So we would say that this is number 1, that multiplication, well, exponents come next, so that's number 2, and multiplication is number 3, and addition is 4. Right, so you just have to remember that little mnemonic, PEMDAS, and remember that that stands for parentheses and exponents. Then that's the order of precedence. So parentheses top of the heap, most important, highest priority. Exponents next. How do we represent exponents in this language? Or if you want to take x to the power of 3, what are you going to type?
Star, star?
Yep, star, star. And then we have MD, which is addition, multiplication, and division. And we have addition and subtraction. And on type. All right, a cute little chart. That's our precedence chart. And once again, I'll say, please excuse my dear Aunt Sally. If that helps you memorize it, great. And I should label what I was doing here. Arrange these in order of precedence. So I numbered them, right. By the way, I only got one question over the whole weekend over homework. I get so lonely over the weekend. Please text me, y'all. All right, let's go to the next PowerPoint. Oh. When you're looking at modules, I think those of y'all who needed to know this have already figured it out. But if you click on lecture videos and you click on YouTube playlist for course, it just looks like an error. But if you click on this thing, it actually takes us to our YouTube playlist. It wants to be viewed in YouTube. Maybe when you're playing on your phone, sometimes you see the error message, this video must be viewed on YouTube using the YouTube app or in a whole window or something. It can't be embedded. This cannot be embedded. Well, it's true that the playlist cannot be embedded either. So you just have to click in and it'll take you to it. And if you notice a missing video, please let me know. I might not be able to get it to show up until the next time we meet in class, but on the other hand, I might be able to. So I do double check, but I don't triple check. So if you spot one, let me know. Next PowerPoint. And in general, anytime you're in this preview window, I just about always recommend that you go ahead and download it, especially if it's a Word, if it's a PowerPoint. It's absurd to try to use this little preview window here. So we're officially done with Chapter 2. Please get the Chapter 2 so-called exam done, even though I don't go in and put dates on them because I want you to be able to keep taking them over and over, so I'm not going to put a due date on it. That doesn't mean you shouldn't take it. It's the best review for the exam possible, and you get credit for it, and you can take it a couple of times and get a perfect score, so why not? Understanding structure. Now, we've been talking about structure the whole time. This may go a little bit faster than chapters 1 and 2 because I've kind of front-loaded the class with a lot of this information already, so that when you see it in the PowerPoint, it'll make more sense. So we'll learn about the disadvantages of unstructured spaghetti code. Then we're going to learn the 3 basic structures, which are sequence, selection, and loop. I consider module calls the 4th basic structure. But those are the 3 basic structures. Why don't we go in and say, chapter 3, 3 basic logic structures. These are the foundation of all programming. Let me cheat. I think I'd have them memorized. I just want them to be able to say them in the order that they've got them. Sequence, selection, and loop. Sequence, selection, and loop. Now we've done sequence already. That suggests the order in which these things occur. If you wrote a program and then you saw my formula, and so you wrote pounds equals, so if you wrote kilograms equals, this is just the same example, you really don't need to type it out. If you wrote kilograms is equal to pounds divided by 2.2, and then later on you had pounds equals input, and then you did pounds is equal to float pounds, that's not going to work. And people get confused why. Well, I put the formula in there, right? So why didn't you do it? They have to be in the right sequence. Kilograms cannot be calculated before we have the pounds upon which it's based. Right? You got to make your icing before you can put it on the cake. It's not just going to work if you put the ingredients for the icing and kind of pour it on top of the cake. These have to be declared in the right order. So we would have to cut this and paste it down here because it's not in the right sequence. It's not a math paper where you can define your formula at the top of the math paper and then and then go on and explain it. Things have to actually be specified in the correct sequence. So the sequence is just the order of the statements. Sequence equals one statement after another. And we can write a program using sequential programming. If we don't have any if statements in it, if we don't have any module calls, any function calls, if we don't have any loops, then it's just sequential. That's all the stuff that's at the same indentation level. If I loaded up one of my old pieces of code here from a prior day, by the way, I love this file, recent file option. Take advantage of that. Don't go looking in your folders for a file if you think you can hit it through recent files. So anyways, here I loaded up. This is sequential. All this stuff is at the, well, these are comments. Let me find one that's not a text file so that we actually get the colors. There's one. All right. Yeah. These are sequential statements, one after the other. They're in a module, so they're indented one level, but they are sequential. And then these are sequential statements, one after the other. And then we have a couple of sequential statements that's embedded inside an if statement. And the if statement follows the assignment here. So they just go in sequence. That's a basic structure of programming. If the program did not know what it needed to do first, then there's no way it could work. So we will learn about how to use a priming input to structure a program. We will learn about the need for structure, recognizing structure, and how to structure and modularize unstructured logic. Okay, really, once we learn these three things, and then we learn this, we're pretty much done with the chapter, because this is just kind of more philosophy than anything else. And they just show they just show some flow charts and blocks of code, and our eyes would roll up if we stared at them too long. So this is the important stuff out of here. That said, we're going to talk about what unstructured spaghetti code is. And this is what code looked like when it was invented in the 50s. Before the 50s, it was all just pure machine language. I think maybe I've already shown you the picture of the ENIAC programmers. All right. What I'm going to note here, there's no screen, there's no typewriter, keyboard. This thing was programmed purely by setting numbers on dials and flipping switches. And it works, right? Yeah, for a computer that has, 1,000 vacuum tubes in it, representing like maybe the ability to store 400 or 40 numbers in it or something like that. Incredibly primitive computers, right? Your microwave has 10,000 times more of a computing functionality than that kind of thing did in the 40s. But flipping knobs and switches would be a really terrible way of having to write, a application that that the user interacts with and that you're expected to be able to update it. You would not be able to write, even a simple application like Notepad or something like that. You'd be a rarefied individual. And, these women were PhD professors at MIT who were drafted into the war effort in order to be able to do this kind of stuff. It was not easy. And the goal of a lot of programming advances were to make things easier for other programmers. Because if you make things easier for other programmers, then they can write better, more powerful programs, right? And so that's why libraries get invented. And that's why new programming languages get invented. But spaghetti code is when the logic just jumps all over the place. And what irritates me is I had a perfect example of spaghetti code that I just stumbled upon reading Wikipedia last night. And I didn't take a picture of it or even remember the keyword I was looking at, so I can't show you. But if I say something like this, and let's pretend that we are going to use line numbers in order to organize things. Because back in the old days, we did use line numbers to organize things. If you had a Commodore 64 or an Apple II or whatever, it came with the basic programming language built in, and you would type in line numbers. Okay, so even using the words that we use, like print and input and something. Print, enter X. All right, that's cool. 20. X equals input. 30. If X equals 0, go to 50. 40. Y equals 1 over X. 45. Oops, I forgot a message. I didn't plan ahead well enough. Go to 60. 50. Print error. Cannot divide by 0. And then 60. Go to 10. Something like that. Oh, and then I realized that I wanted another line in there that said if X is equal to -1, then quit. So 35. If X equals -1, quit. All right, now hopefully I can relist the program and it'll insert 35 back in there. But if we're trying to figure out the logic, what's it doing? It asks us for X, it lets us type it in, and then it checks. Is X equal to 0? will jump to 50. Print error, divide by 0. We should not have been trying to divide by 0. And then go to 10. Okay, it goes to 10. Print enter x. We type it in. If it's equal to x, no, it's not. Well, then it was supposed to run this. Is it equal to -1? No, it's not. We typed in 2. All right, so y is equal to 1 over 2. Go to 60. Go to 10. Right, it's just going all over the place. That's spaghetti code. It's possible to write programs that way. The Apollo moon landing programs were written like that. So if it can send a spaceship to the moon, then it's certainly functional. But it's really hard to maintain. It's incredibly. You would not want to have to write large programs like that. If we go and look at the Apollo computer program, and we find an example of it, that's not an example I want to show. Oh, phooey, I'm not finding it. If I don't find it in 15 more seconds. Phooey. All right. Here's an example of what they were doing back then. Here's the comments. There's almost more comments than there's source code in order to make very clear what the program's doing. Because without these comments, you would not be able to read that at all. And they probably have jump statements, going from one place to the other, just kind of like my code did with the go-to statements. That's spaghetti code. We want to avoid spaghetti code. Fortunately, in this language, there is no go-to statement, so the ability to write pseudocode is dramatically hindered. The fact that programming languages stop using the go-to statement in place of our structures, using the structures of selection statements and loops, using if statements and loop statements, eliminated the need for go-to statements. Kind of got rid of spaghetti code. So spaghetti code, logically snarled, often a complicated mess. The programs might work, but they're difficult to read and maintain. And they're confusing and prone to error. So an unstructured program does not follow the rules of structured logic, whereas structured programs follow the rules of structured logic. Well, it's kind of a tautology there, right? But an unstructured program is one that's not structured using the things that we're going to be talking about: sequential statements, loop statements, and decision statements. Now, our language forces us to use loop statements and decision statements. So automatically, we're writing at some level structured programs. However, our structure can always be improved, right? One example of poor structure is if I was looking at my code here, and then I started embedding functions right in the middle of it, define something, and then later on I called something, and maybe I called it up here inside this block of code, blah, 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 way up here, I called something way up here, something like that. Things are defined out of order, maybe it works, it's harder to understand. So you're trying to write your code so that it's as easy to understand for the reader, not for the computer. The computer doesn't care that I called the function before I defined it, but it's easier to read the program if I define that function up at the top of my program, just like I did with the poem function, if you remember the poem function. If I cut this and I pasted it way down at the bottom of my program, it might still work. But why would I want to do that if I could put all of my modules up at the top of the code where they're easy to find, and then my code that called those modules was sequentially written underneath it? Now, when I'm giving examples, though, quite often I will write the function right there and then I will call it. That's not good programming structure, but that keeps the function right here, the module right here in the example, so that we can see how it was defined and how it was called. If I was going to turn this into professional code, though, I would cut and paste my modules up near the top of the program. Just like a good essay might need to state its goals, what it's going to talk about, and you would put that up at the top. Or if you're preparing a PowerPoint and you're going to list the bullet points that you're going to talk about, you'd stick that up at the top. It would be absurd to stick this thing here, our objectives, at the very end. Or, you know, to stick the summary of the PowerPoint in the middle. Technically, it's okay, it would work, but it's stupid design. So here's an example of unstructured spaghetti code. And again, it's something that we just flat out cannot implement in a modern language, like in Java or Python or something, because there's no go-to statements that would let us code this. But you can write a flowchart that is flat out impossible to implement in the program, just because they have lines joining where they're not supposed to be able to join, and so they're not following the programming structures that we're going to be talking about. Okay, so the basic unit of programming logic. Sequence, I've already talked about sequence. Selection structures, decision structures. I'm going to put one more thing in here, if statements. These are what selection or decisions are, if statements. We've used if statements a little bit. And then the loop structure. I may have given an example or two of loops, but we haven't really talked about them much. So any program can be constructed using these three structures. You just mix and match them as you need them. They're the fundamental building blocks. And if you're playing Minecraft and you have these certain blocks, you can build anything out of the blocks that they give you. Same thing here, right? We have these programming structures. We can embed them inside each other. We can list them one after the other. We can have selection statements that then have loops inside them. But fundamentally, they are these three structures. And I really wish that they listed the fourth one, which are modules. I consider a module a separate structure just because if we're looking at the source code, where'd that go? This module is kind of asynchronous, right? We print out our poem, then we have a sequential statement after that, and then we print out our poem again. But each print out the poem kind of does a go-to up here, executes these lines of code, and then returns. And you could argue that that's sequential, but it's listed in its own place, and you write one piece of code so that it can be called in multiple times. So I consider that a separate structure, but this textbook does not. So we'll go by the textbook on the exams. Although if I asked you to list three programming structures and then you said modules just because you saw me type it up here, I certainly would not count you wrong. So sequence structure, that's your actions that are in order. No branching or skipping any tasks. They just go straight in order. Then the selection structure, that's your if statement. You ask some kind of question and you take one of two actions based on testing it. If x equals 0, then print error message. If x equals invalid message, quit program, right? That kind of thing. So those are selection statements, selection structures, decision structures, if statements. I'm going to go back here and I'm going to add those to my notes. So sequence is one statement after another with no skipping, no branching, no looping. I don't want to say that. I just want to say one statement after another. And then a selection structure is a decision, which is an if statement. And then lastly, loops are repetition. Loops are repeating a block of code a certain number of times. We want to draw 10 triangles on the screen. We may loop that has the triangle drawing code only in one place, and we just tell it to repeat it 10 times. So that's our third structure, the loop structure, repeating code. Okay, be a good idea to give ourselves examples of all three things. So eventually I'm going to load up idle, and we're going to write a program that does that. So sequence, one after the other, same indentation level up. Everything at the same indentation level is considered a sequence. Selection structure, it's either a yes or a no. Right? If something's true, then go that way. If something's not true, then go that way. If temperature less than 32 degrees, print the weather is icy. If temperature is greater than 212, print water is boiling. That kind of thing. So there are two kinds of if statements. There are single alternative and dual alternative ifs. Please don't bother taking the time to draw the flow chart. That's going to be the example that I give you. Just pretend this is a PowerPoint. Come on. Yeah, whatever. Okay. So a single alternative is when it's either something or nothing. Right? We have some process up here, and then based on that, we're going to ask logically some question, right? Like if x equals 0, then we're going to print out an error message. Nah, let's make it my example that I gave up here. If temperature is less than 32, we're going to print a freeze warning. So it goes out here, and what shape is the print statement supposed to be in out of all of these?
Tilted?
Yep, tilted rectangle. Data block. So we're going to print ice warning. Then we're going to come back down here, and it's going to join up. Where's my circle? Fine. Circle's off the screen. Right. Hooks up with something. Hooks up with something. There we go. It's something or nothing. That's a single alternative. Single alternative selection. Because it's something or nothing. Yeah. Now I'm going to go and put that in my notes as some code. And then you know the logic keeps going on from there. But you can see that. Do something or nothing. If your kid did something wrong, you yell at them, but we're not parents who believe in positive reinforcement, so we don't do anything if they do it right. Kind of lame, but okay. So here we go. Selection is conditionally doing something based on testing a value. That's my way of wording it. That's not the book's way of wording it. If x is 0, then print an error message. If age is less than 17 or less than 18, print you can't vote. Print an error, else tell them they can vote. Something like that. Of course, conditions for voting are probably a little bit more complicated than that. I would imagine you have to be a United States citizen, and some states don't let you vote if you're a registered felon, right? There's more conditions than that, but still, that's conditional logic. So single alternative is something or nothing. If temperature is less than 32, print freeze warning. like that. Now, if you were typing all this into idle, remember that you better have started it with triple quotes. I could just copy and paste this into idle. I'm not gonna though. Okay, so I'm gonna add a comment here. If the temperature was not less than 32, we don't do anything out of the ordinary, right? It skips it, and then it just goes to the next statement. We just go to the next sequential statement. Just go to the next sequential statement. So this is the conditional statement. It can be an entire block of code. As long as it's all indented, we could have 2,000 lines of code that was indented there. So that's a single alternative. A dual alternative is something or something else, thing 1 or thing 2. If age less than 18, or not registered, print, you can't vote. Else, print, go vote today. And to be proper Python, every one of these statements has to have a colon after it, that one and that one, because every time you start indenting, the line above it has to have a colon. Just like I did up here. It's not true of all languages, it's true of this one. So this is dual alternative, do something or do something else. If you were going to draw that on a flow chart, you'd have 2 branches. So this is a dual alternative. We better have something else on the other side. Now I like drawing the dual alternative so that it actually branches off to the other side, but you could just put it underneath it. But I think it's clearer if the no side goes off in the opposite direction. So print OK if the temperature is not less than 32. And then hook back up. Single alternative, do one thing. Dual or nothing. Dual alternative, do one thing or do the other thing based on the test. This is the test. That's called the test expression here, right? We're doing that test there. Well, the program's doing the test, not us personally, in order to decide which branch to take. For some reason, they mentioned dual alternative first. So if some condition is true, then do process, else do the other process. Notice this word here, then. That's because it sounds good in English. We don't actually have a then statement anywhere in this code. We don't have a then statement anywhere in our flow chart. If you felt like it, you could, if you really wanted to put the word then in here, you could replace that yes with a then, and you could replace this no with an else, right? Now, nobody does that, so I wouldn't do that. That else word is something else to notice. It's in programming code, but it's not in the flowchart. Proper flowcharting. I'm going to undo those changes because that was not proper flowcharting. Notice that there's no else in there. People get into the habit of wanting to do a one-to-one correspondence between source code or pseudocode and the flowchart. They want to see every statement here over here. So as they're reading it, they want to see that if statement, they want to see the print, and then they want to see the else. And so they go, oh gosh, I need a else. I wonder what an else is supposed to be. Oh well, maybe it's another diamond. So I'm going to put a diamond here, and it says else. No, there is no else in flowcharts. It's just the no branch. So I'm going to get rid of that because that was not correct to have that there. And like I said, if you really want to see the word else, you can put it there as part of the no branch, right? You could say no/else if you really felt the need. If you're sitting there looking at a flow chart and you think that there ought to be an else block somewhere, just put it next to the word no. Leave it off. Less typing. Single alternative. If the employee belongs to the dental plan, then deduct $40 from their pay. No else is required. If it's pseudocode, then there's usually an indif there to mark the end of it. Pseudocode for this one also has an indif. So I don't know why they left it out here. Technically that should have been there because this is definitely pseudocode. It's written in English. The null case is when nothing is done. Null is a fancy word for nothing. In our flow chart over here, this is the null case. If temperature is not less than 32, then do nothing. So that's the null case. I guess I'll add that back up to here. If the temperature was not less than 32, do nothing. So that is the null case. Single alternative, something or nothing. Said that 17 times. I'm going to skip saying it. All right, the loop structure repeats a set of actions while a condition remains true. I think we ought to actually start writing some idle code because that's more interesting than just taking notes. And so we're going to illustrate a loop structure. But we're going to add the note for what it is first. Loop structure, also known as repetition. I think they gave one more term for it. Iteration. Okay. Let's throw that word in too. Now we all know what repetition means, but we probably don't think in terms of iteration. That's a nice computer scientist term. Iteration is like if you're at Walmart and you're shopping for something. You have a shopping list. What are your steps? Look at item, wander around the store helplessly until you find the item, put item in cart. Then you're going to check to see if the list is empty. If you're at the end of the list. No, you're going to repeat those steps. That's called iteration, repeating the steps, right? So I found the item, I put it in my cart, I checked the list. Yep, I still have more to go, so I'm going to reiterate. Hey, that is English. We do say reiterate, repeating my statement. All right, let's actually get some idle going. December. Where did I come up with that? June 24. I'd appreciate it if you always put your name up here.
Does it matter which order it goes in?
Nah, the program works just as well. Usually I stick my name at the top, I think. These are just comments. These are labeled. If you work at a big company, they may demand that certain statements in your comments follow other comments. I think that's good enough. Chapter 3, logical structures. Let's do some sequential structures. So let's do some declarations, just to be like the book. We're going to say that num is equal to 0. And then max, no, that's a bad word because it turned out it's purple. Okay, max underscore num equals 10. Right, so those are our declarations. Now this actually could probably be declared as a constant because I'm not going to change my max num during the program as I'm thinking about it. So I'm going to make that in caps just because it's a constant. I could add some comments to the effect that this is the number of messages we will print, and this is the max number of messages. And we're going to need some kind of counter to count how many messages we are printing. So, counter equals 0. Current message number. All right. I'm trying to structure this in such a way that I would not be ashamed to show it to another programmer, right? So I'm adding lots of comments and stuff like that. And I'm kidding about feeling shame, but so that I could come back and review the code and understand exactly what it's doing later. All right, now we're going to do the sequential code. I could do some pseudocode first to explain what we're doing. Now, the declaration should have been part of the pseudocode, but honestly, I don't feel like repeating. I guess I could. All right, so quote, 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 pseudo, how do you spell pseudo? Yeah, E-U-D-O code. All pseudocode starts with the word start, even though it's not in our programming language. Everything after that is indented. And so we're going to have some declarations, colon, and we're going to declare our stuff. And I think they show the declarations as being tabbed over, but I'm not gonna. Set num equals 0. Set max underscore num equals 10. Set counter equals 0. We already kind of see the difference between the pseudocode and our real code. In this case, you just have to leave off the word set when you start trying to write some Python rather than pseudocode. So what is our program going to do? Output, quote, how many messages to show, question mark. And then input num. Now, if our number, if they ask for 1,000,000 messages, we're not going to let them do it. So we're going to compare the number of messages against max num. And we're going to cap it at max num. So if they type in 1,000,000, we're going to set num equal to max num, right, to 10, so that we only repeat 10 times. So that's a selection. If num, now I could type out the words is greater than, since we're doing pseudocode, but honestly, I don't mind using some math symbols. So if num is greater than max underscore num, then tab print or output, quote, capping, you know what capping means, right? Setting the maximum, capping messages to the max. I don't know if that makes sense. Capping messages to end quote, comma, max. End quote, caps, maximum. Else, wait, we're not done with that. Then we got to set our num that they typed in equal to max num, because we have indeed capped it. So num equals, quote, max underscore num. Now we're done with this block of code that was nested inside the if statement. End if. Again, end if is something that's not in our language, we can add it as a comment if we want. In the flowchart, there's no end if word. It's just a circle at the bottom where the things hook back up together. Is this a single alternative or a dual alternative? How can you tell? If there's no else statement, it's not dual. It's something or nothing. If max num is greater than, if num is greater than that value, then we do something. Otherwise, we just keep plugging away. Okay, now we're going to have a loop. In order to write this loop, we're going to set counter equal to 1, and we're going to keep repeating the counter while it's less than num. There's our secret word, while it's less than num. So we're going to be using the keyword while in here. But in order to start counting, we need a variable, our counter, so that we know how many times we've repeated. So counter equals 1, that's where we're starting. And then while the counter is less than the num, I should have chosen a better variable name than just num. Right, num underscore messages. It just would have taken longer to type, so I made it num. Maybe that's too brief, maybe that's too terse, too abbreviated. Okay, so while the counter is less than num, we're going to output quote message number space end quote comma counter. So it'll print message number 1, message number 2, message number 3, and so on. Now for it to do that 1, 2, and 3, we actually have to change the value of counter. Now again, since this is pseudocode and it's loosey-goosey English, we could express that in lots of different ways. We could express it like this. Add 1 to counter, or increase counter by 1, or increment counter by 1, or set counter equal counter plus 1. That would be the most programmy way to do it. But since this is pseudocode, I'm going to do that. End while. And just like end if, there is no end while statement in our Python language. It's just in the pseudocode. If we feel like seeing it in our Python, we can add it as a comment. Put a hash sign in front of it and we're good to go. And then why don't we print a done message or output? I don't care if you put the word print in your pseudocode rather than output, but I'm doing it to the book style. Output done, period, end quote. And now since this is the end of our program, we're going to have a stop marker, just like we had a start. So I'm putting stop right there at the very bottom. Okay, so that's my pseudocode. That's the logic for my program. I could go and flowchart that. Guess what? We're gonna flowchart that. Then we're going to take our break and come back and write it in Python. We haven't seen how to flowchart a while loop yet. But after we draw the flowchart, you'll know how. Why don't I show that in Python? What page are we on? I mean, in the PowerPoint. We're on page 12. Oh, there it is, right? Except I draw it a little bit differently, but this is correct. We have a decision diamond. We do some code, and then instead of them joining back up in a little circle, like if it was an if statement, it comes back up here to repeat it. You know, keep going through our shopping list. Keep driving until we hit the destination. Keep adding 1 to our counter, right? So it's going to keep repeating it. Now, when I draw it, I make it actually hit the diamond, either there or there, rather than loop above it. I think that's a little bit clearer. If you draw it to the book format, that's fine. If you do it like the example that I'm just about to show you, that's also totally cool. All right. Why don't we all go to Lucidchart? If you haven't already, if you have a Lucidchart account, which is just your school account, Did anybody miss Wednesday and not get to use Lucidchart? Cool. Okay. So, if I put my pseudocode on the screen, it'd be a lot better if I actually cut and pasted it into a comment block. I like seeing your code on your flowcharts. Makes it easier for me to know if it also makes it easier to write, especially since I can only really have one thing on the screen at the same time, unlike y'all with your smaller fonts. So I'm just going to highlight everything from start to stop. I'm going to go and make a new document. So over here in Lucidchart, I'm going to do File New. Now I may actually skip that step because I'm going to put all of our notes in the same document. Now I need a place to type in my code. So I'm just going to put the big old block up here. Yeah, you could choose that block, but whatever. There's a great big block up here. I suppose I could even choose one of these funny colored ones, but I'm not gonna. Drag that over here. I'm going to paste my code into that place where it says text. It's going to look nasty. I might not count off if you leave it looking nasty, but it sure would be better if it was all, you know, oriented against the margin. So I'm going to stretch it out. And then I'm going to orient it against the right margin. Excuse me, the left margin. So I'm going to double click on one of these words. Ooh, it highlighted everything. If it did not, you could click on the word start and drag down to the word stop. Or you could click on one word and then you could hit Control A or Command A on your Mac and it would highlight all the text. Control A just means select all. Then I need to find the alignment tab. Might want to let me get rid of that. Whatever. Just like in Word, it's that thing. And I'm going to choose to tuck it against the left margin. So that's my code. Since I've reformatted it, my block can be smaller. There we go. If you feel like being artistic, you could figure out where to choose a different color for it. I would really like it if you put your name on your flowcharts. So you could either put your name in your code, or you could just put, you know, some kind of text up here, right? Jeff Thompson, CIT 1113, Chapter 3. Something like that. If it was homework, you'd put, you know, homework 4 or whatever. All right. I could ask you what kind of shape to put a start in, but we already know that. It's an oval, specifically called a terminator. Some textbooks, maybe this one, call it a capsule. It's a terminator. I almost did my Arnold Schwarzenegger imitation, but it's so bad that I'm going to save y'all. Okay, here we go. Terminator. Start. To give I was about to say, to give myself room for the left and the right, I'm going to drag the oval over farther to the right. But looking at my code, there are no else statements. So I'm not going to have any lines jutting off to the right. So I'm going to make a calculated guess that I don't need to go to the right. Now I am going to make my ovals as small as possible. You don't need to do that, right? Because you're not trying to conserve screen space the way I am. You can always zoom in and out. How did I zoom in and out so fast? I held the control key, or the command key for the Mac users. Hold the control key and spin the wheel and do that. Now honestly, you laptop users, I don't really know how to do it. I'm sorry.
Control plus or minus.
Okay, control plus or minus. That's cool. Perfect. Control plus minus. Perfect. I like that. Thank you. I'm sure that you could also hold control and maybe do a 2-finger stroke on whatever. Control plus and minus is perfect. Okay. And then some declarations. Now there's no blank lines here to show the end of the declarations. And if I wanted to make my pseudocode prettier, I should have put a blank line. Maybe I'll add a blank line to my comment here. So I'm going to double click on the first word output and hit enter. And then space it over 4. 1, 2, 3, 4. And I think that, like I said, the textbook shows tabbing the declarations over a little bit more. I'm not going to do that. Declarations are the only time when it's okay to put multiple lines of code in the same block. So I'm going to move my cursor underneath the start block, click on the red part, pull down, and I'm going to choose the rectangle because declarations are just a form of math, like x equals 3. So that's a process block. I'm going to put the word declarations in here, colon, and I'm going to hit Control Enter, Command Enter, and I'm going to type them in. Set space num equals 0. Control Enter. I wonder if Shift Enter also works. Set caps max num equals 10. I'm going to try Shift Enter. Ooh, even better, because that certainly would not differ from the Mac users and the Windows users. And then Shift Enter, set counter equals 0. If you feel like it, you could mess with the margins and stuff. I'm not gonna. I'm gonna just leave that as is. If you don't let me get rid of that blue marker, I'm gonna start crying. Okay, finally. No, it came back. Right. All right, then we have an output statement. Now, I've already asked y'all what an output statement goes in, so that's a tilted rectangle. Output quote, how many messages to show in question mark. Now that looks kind of lame. Maybe I'll try to stick the word output on its own line, so I'm going to move my cursor above in front of the quote and hit enter, or you can resize it. And once you resize it, then the lines don't line up anymore. I don't care if your lines line up anymore. I'm going to be a perfectionist up here and waste time lining it up, and instead I'm just going to leave it like that. There's our story so far. We've hit the bottom of the page, pretty much. I could draw a little circle here and another circle at the top and keep going, but nah. These things just, you know, the program just tacks on a page when I need it, so I'm not going to fuss with it. Now we need an input. After our output, which is technically called a prompt, we're going to input. Input num. That's the number of repetitions we're going to go. All right, I'm going to show you all a sneak trick. If you ever need to hook a whole bunch of sequential statements up with arrows, it would be okay to draw just one arrow and send it to the back. Now don't delete your stuff just to do what I did here, right? But you could do that, and then you could right click on the arrow and choose arrange send to back, right? That looks just about as good. Yeah, we don't have arrowheads for everything, but you know, time is of the essence. And if you're doing this on an exam and you realize you haven't added a whole bunch of arrows to, you know, the blocks, you could do it that way. All right, so after input number, if I look over here, we have an if statement. That's a decision block. Now the textbooks don't show putting the word in here. The textbooks would just do this. Num greater than caps max underscore num. I like seeing the word if there. Why? Because the same block is used for while, right? I like visually distinguishing them so that it's instantly obvious what I'm doing there. And I'm the boss of my flowchart, so I'm going to go ahead and stick the word if there. So I'm going to type in if, shift enter. Oh, well, that doesn't look too good. All right. Now the code that's indented, I'm going to jut off going to the right. And all the code that's indented past that point is then going to be off to the right. If I had an else, I'd probably draw it jutting off to the left. In general, I try to make this kind of match the structure so that each time we indent, we have a new column. The only time that doesn't work is the else, since they like I said, veer off. You know what? Yeah, they veer off to the left. Okay. So, if the number is greater than the maximum, we're going to have an output statement and then a math. So we're going to put a data block. If I looked at my own screen, I could do this more easily. Data block. And we're going to have a math statement. My math statement disappeared. A process block. There. Data, process. Inside the data block, we have an output, capping messages to, comma max number. So output, shift enter, quote, capping messages to, end quote, comma, and I don't care if you use shift enters or not, all caps, maximum. You might try to make it look nice, but like I said, time is of the essence, and if your text is going out of bounds, I'm not going to grade your coloring book on whether you went outside the lines. Then what's the next statement after my output statement? Somebody will look on the code and scroll off my screen. Indif is actually after the process block. There was something after the output statement before the indif.
Num equals max.
Yep. Set num equal quote or caps maximum. And then there's an indif. We don't have to put the word indif, but we do need the little circle where the lines are going to hook back up. The circle's going to have a letter in the middle of it. You can just delete that letter. I'm not going to count off if you leave the letter, but it sure is prettier if we delete the letter in the middle of the circle. Also, the circle is way huge. We could squeeze the circle down as small as possible, but then it starts looking like a funky oval. Whatever. Your lines do not have to be exactly the same. If your lines have angles, no problem. If you drew a line coming off the bottom of that block rather than off the side, no problem. If you drew your flow chart and then and it kind of wandered off in a diagonal direction, well, technically the logic is okay. It's better to make it look more structured, but unlike the programming language,
It's not going to count off for tabbing it incorrectly as long as you have the logical blocks, the statements in the correct sequence. Alrighty, now we have a while loop. No, we don't. We have a set statement. Counter equals 1. I should have put the word set in front of it. I goofed up in my pseudocode. If you feel like correcting it, great. If you don't, you know, whatever. So I went back to my code and I added the word set in front of counter equals 1, just to be as perfect as possible. I'm not expecting you to correct my mistakes on an exam, by the way. Okay, so come down here. This is what kind of statement? What is a set? Oh, well, there's already an example right on the screen off to the right. It's a process block, so it's a square, a rectangle. Set space, counter equals 0. Then there's a while. While counter is less than or equal to max num. I hope I made it less than or equal to and not just less than. Okay. I have a logic error in here. I guess I'm going to leave it since it's in my source code in 2 places. Yes, ma'am. Well, I said we were going to do it after the flowchart, but the flowchart's taking a while. Let's take a break. Good idea.
Also, did you have to take attendance?
Not yet. I'll do that when I get back. Thanks. It did it again. All right, there we go. I'm going to save my work just because I'm paranoid. So file, save. I think we're on G. Extra G. All right. Alrighty, so now we're at the point of our while loop. While counter less than num, output something, add 1 to counter. So while is just like an if, except that the very bottom of the line doesn't go to circle, it goes back up to the diamond. So while counter is less than num, and by the way, that's a logic error. It should be less than or equal to, but I'm just leaving it as is because the code shows that. Now, if that's true, we output our message. Output message number. Okay. Output quote, message space, number, end quote, comma, counter. Oh, Anna just pointed out something, or on hers, when she right-clicked and tried to do paste, it gave her an error message, which is stupid. But the error message was use the control keys. Now, why her browser's behaving differently than mine, I'll never understand computers. They should all do the exact same thing when you repeat the same steps. But anyways, so if you get into that case where it wants you to use control keys, the 4 most important ones are the Z, X, C, and V. Control C for copy, Control V as in vehicle for paste, X for cut, and Z for undo. I love Z. Wail on Control Z when something wrong happens. And then, after that, most of our spaces were gone. So we tried changing the font. Would you? Okay. So we went up here and we played with the fonts until we found one that looked really good. This one called Kusign. Well, you may have heard of, oh gosh, what's the term? The proportional fonts versus the, anyways. It's the one where every letter is the same width. So, That helped it a little bit on hers. And then since that still didn't look right, we went back in and we added spaces by hand to make it look right. And that should not have been necessary either. And so I apologize for you that you're having to go through separate steps. All right, now I'm going to undo my font change because it looked fine on mine. And of course you can change the size of the font, change the color, and so on. I use colors in a very specific way. I don't care if you feel like making your chart pretty with colors or not. You'll see the specific way when we hit the drawing modules. Okay, so output the message number. What's after the output message number statement? Somebody look at our code. Tell me what the next thing is after.
Add 1 to counter.
Yep. And that's what? That's math. So it goes a process block, a rectangle. Add 1 to counter. In my code, I'm going to make that counter equals counter plus 1. Or maybe even a shortcut abbreviation for that, counter plus equals 1. Now, if this was an if statement, don't draw this because this is not correct. I'd go down here to a circle, you know, and have 2 lines going to the circle. But this is a loop, so it's got to go back to the while statement. Here's what the textbook shows is going above the while statement like that. Something like that. If you think that's cool looking, go for it. Here's how I do it. I draw the line going back to one of the edges, the diagonal edges of it. I think that's easier to read.
If you feel like doing it the book way, where you draw the line going above the diamond, that's cool.
Does the book show a word on this line coming down from there? Yeah, I guess they do. Okay. For some reason it looked a little strange to me. And then it's a print done message, I believe. An output done. So one more tilted block, data block, output quote, done. Or program done, or whatever my message was. Oh, I guess I didn't put that there. I meant to. Well, I'm going to delete that to make it match my code. Instead, it's just a stop. So it's just going to be an oval. Terminator. Now, something I've seen people do in their flowcharts when I assign flowcharts is stick the declarations block above the start. Technically, I'll have to count off for that. The book doesn't show that, and I don't show it, but maybe it makes sense to people. It must make sense to people because more than one person does it. Just remember, start actually is the top. When more than one person does it, I know that something logically, you know, makes sense about it. But okay, so that's our flowchart. I'm going to zoom out temporarily, see if I like the way it looks. You can kind of see how it, you know, this font is teeny tiny and you really can't see it. But if I temporarily increase the size of the font, we will see that the structure of this and the structure of this kind of match, right? Where there's a texture tab over here, we see it jut off like that. When the tabbing is done, it comes back. And then down here for our while loop, it juts off like that and it comes back. Notice I left off the word endif here. If you really felt like it, you could put an endif inside that circle. I wouldn't bother. And really there's no place for an end while. So there's not a one-to-one correlation between pseudocode and flowcharting, but that's okay. Flowcharting was invented before computers, so they don't have to match. Just like there's not a one-to-one correlation between pseudocode and Python. In Python, it might take 2 or 3 statements in order to do what it takes in one statement in pseudocode. That's okay. Just pseudocode is the logic, right? Just like add sugar to your recipe, that's actually probably more than one step, right? You grab the measuring cup, you pour the sugar into the measuring cup, you dump the sugar into the bowl, you put the measuring cup down, right? That's like 4 steps where the recipe just said add 1 cup to bowl. Same thing here. When we do this input statement, I know it's going to take 2 input statements because we're going to have to convert it to a float because it's a number. I think I'm going to undo all that. I don't know, I may leave it next to the flowchart over there. I should just hit Control Z a few times, get it back to where it was. Control Z, Control Z, Control Z, Control Z. Okay, so that's my flowchart that matches that logic. Why don't we implement that in Python? It's always satisfying to actually write a program. Anybody need this flowchart on the screen anymore? Catch up. Nope, all good? All right. I'm going to go back to idle. I haven't saved that either, which is always risky. You never know when we're going to have a power fluctuation. These computers are not on uninterruptible power supplies. So File, Save As, G, Lecture G. Now there was some correction I made and then some correction I didn't make. Oh, the word set on counter equals 1 in my pseudocode. I am going to add that, but I'm not going to correct the logic error. The logic error should be to put an equal there. Why? Because if we're starting at 1 and we keep going while it's less than num, that's just going to be 1 through 9. And if they typed in 10, we actually wanted to go 1, 10. Oh, heck, let's fix it. All right. Oh, there's my output done. It's out of place. Well, I'm going to delete it then. Triple quotes. Let's actually write our program. I'm going to put start there. It's not a Python command, so I'm going to put it in a comment. Since it's just a comment, I'm not going to actually tab it after that. Remember that after every colon you have to tab in Python, but these things are just going to be comments, so we're not tabbing that. But we have some declarations, colon, and again, the program would work just as well without these. The book shows us commenting our declarations, I believe, so I'm going to do the same. I'm wondering if I could copy this, paste it into my notepad, get them both on the screen at the same time so I don't have to keep scrolling up and down. Good enough. All right. So my declarations. And again, since that's a comment, I'm not going to tab this stuff over even though the book shows it. Num equals 0. Max underscore num equals 10. Counter equals 0. If I was a good programmer, I'd add comments. Now this is annoying. When I was at that 0 and I hit tab, it pulled up that annoying little thing. It's trying to help me write code. It's listing a bunch of things that it thinks I might want to put there. Now, what the what? I don't know why it's letting me choose those, so I'm just going to hit the space bar rather than tab, and then I'm going to hit tab just to force it to let me tab it over. All right, and so this is number of messages to display. Number of messages to display. Now this one's pretty much real obvious. It did it again, so I'm going to hit space and then the tab, #, maximum of messages. And I'm sure it's going to do the same thing here, so I'm going to hit the space and then the tab, and this is going to be the current message number. Current message number, or what was the second choice you said?
You put current.
Yeah, current number. That's brilliant. Thanks. Current message number. Okay, cool. I may have said this before, but there are companies that pay to actually have two programmers sitting there staring at the same screen. That would drive me crazy. But you catch errors that way, a lot of errors. And they think the increased productivity is worth doing that. Okay, so output how many messages? Well, we don't have an output command, but we have a print command. Print parentheses, quote, how many messages to display, question mark. I don't care if that matches my pseudocode exactly or not. Okay, I use the word show. I guess I'll make that match. Show, question mark, end quote, in parentheses. And then it's input num. Well, that's not Python. That's not valid syntax. Bless you. Python is very picky, so we're going to follow the Python syntax. Num equals input, parentheses, in parentheses. And I personally like putting a greater than sign to let them know where to type, so I'm going to put quote, greater than, end quote. That's not part of the syntax, but it helps in my mind. Now, I could actually put this message right here inside the input statement, but I'm following the pseudocode explicitly right now, pretty much. Okay. Unfortunately, in Python, unlike some programming languages, that's not quite enough. We have to convert that variable to a float. It's just inevitable. It's just a law of Python. After you let them type a number in, you have to convert it. So num space equals float space num in parentheses. I could add that to my pseudocode. Convert num to a float. But then the programmers who use C++ or Java or some other language where that's not a necessary step will be annoyed to see extraneous steps in the pseudocode. All right, now we have our if statement. I'm going to put a comment up here saying prompt user for num messages. And then I'm going to add another comment. Make sure max, make sure num is not too large. Again, I'm going full tilt here. That's why I'm adding so many comments. The closer you make your code match the number of comments I have here, the happier I'll be. Doesn't mean I'm going to count off for not enough comments unless I explicitly say so in the instructions, which I haven't so far. I'm not sure if I'm gonna. Okay, so if num greater max underscore num colon, because we have to indent. It's our first indentation. Then we need to print a message. I could just copy and paste it, but print parentheses quote capping num to, or at, what did I put there? 2. End quote, comma, quote, caps max num in parentheses. And then num equals max num, max underscore num. Now our pseudocode shows the word endif. That's not part of the Python syntax. I could leave it out entirely, or I could just put it in as a comment. Now what is the next part of the code doing? It's looping to display the messages. I may as well add that as a comment. Loop to display messages. Now, why am I putting those blocks there? They're kind of like if I need, I'm going to tab away from this for a moment. I could outline the structure of my program like this. Declarations, get input from user, perform calculation or perform error check, and then loop to display messages, right? That's the general sequence, the 4 steps, broadly speaking, even above pseudocode, that my program's going to do. Just like if I was going to bake a cake. I might bake cake, I might make icing, I might apply icing to cake, right? And then I need to put specific instructions in my recipe for that, but that's what we're doing here, and I'm making the comments kind of match that concept. So if I gave you a broad list like that, you could actually just turn those into comments and put them into your code. All right, loop to display messages. While, uh-oh, I forgot something. What's next in my pseudocode?
Set counter equals 1.
Yeah, set counter. So counter equals 1. While space counter space less than max underscore num, but that's a logic error, so I'm going to correct it. Less than equal max num colon. Since there's a colon, I need the next statements in that block tabbed over. We're going to output our message. Output quote. No, there is no output statement in Python. Print, parentheses, quote, message number, end quote, comma, counter. What does that mean? It means print the message to the screen. Everything I want printed in the screen has to be between the parentheses, and the individual pieces of data that I want to print are separated by commas, which turn into spaces when they're being displayed. And then I believe it's add 1 to counter. Well, that's not Python, so we're going to do counter equals counter plus 1. And if we wanted to be fancy and shorter, I would have done counter plus equals 1. And you'll see me do that in later programs just because. Technically, this is known as incrementing. So in my pseudocode, I could have said increment counter rather than add 1 to counter. But, you know, we're trying to make it readable to people who aren't computer PhDs yet. So that's why I use the English non-computerese version. There we go. I believe that's the end of my while block. Yep, it was only 2 statements. Just like end if, there's no end while. So # end while. And then if I had a done print statement like I'd planned, I'd put it underneath there, but I don't, so I'm just going to put a stop. That's my program, and if I've made syntax errors, it's not going to work. You know, one thing that I don't do, that I probably could try, is to do run check module. That does a real cursory syntax error check. It doesn't catch everything. All right, I usually just run it, find out if it runs. Hop in the car before I test it out. Run module. How many messages to display? 5. Message number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I've made a mistake here. I wonder if I made that mistake in my pseudocode. No, I did not. But does anybody see the difference between my pseudocode and the real code in my while loop? If I put them right next to each other, it's going to be real obvious. Right? Now they line up. What's wrong with my while statement? It's just like one of those spot the differences between the 2 programs. I mean, between the 2 pictures. Just read the line while counting. Yeah. So maximum was 10, so it's always going to print 10 messages. That's not cool. I wanted to print the message that the user asked for, which is not maximum, which is not capitalized at all. It was lowercase NUM. So NUM colon. I just changed that line. How many messages to show? 5. Message 1, 2, 3, 4, 5. All right, we have demonstrated all 3 logical structures. We've demonstrated sequential. Some more sequential. This if block is also sequentially located underneath that stuff. But then these statements are conditional. So this is a selection block or a decision block. I may use the term decision more than selection, but they're equivalent. If you write one down, now most of my questions are multiple choice, but you know, but if you filled in a blank and you put decision rather than selection, I'm not going to count you off because I use both terms. Alrighty, and then this code is inside the if statement. It's a single alternative. It only does this if this case is true. This is called the logical expression or the Boolean expression, because Boolean means a logical value that is either true or false. Let's get techie about it. This is a Boolean expression that evaluates to being true or false, and if it's true, it performs this code. This is the yes block on the flowchart. Some flowcharting programs actually put the words true and false there. And then this while block is sequentially located under the if statement. So again, that's more sequence. And then this is the repetition, the loop. And this code, since it's indented in here, only continues repeating while this is true. It's just like an if statement. If that said if, we would know that if the counter was less than num, do this stuff. Otherwise, don't. While is the same. Whoopsie. While the counter is less than 10, or less than our num, do this stuff. I'll do a walkabout in a second, make sure nobody has syntax errors. But the difference between if and while is that since if just joins in a circle and keeps on going after it, it doesn't repeat. A while does repeat. So it adds 1 to counter and then it checks again. Yo, is counter still less than or equal to num? And if that's the case, if it's still true, it repeats it, and it keeps repeating it until its expression is no longer true. And then stop. So this is well-structured code. It's not spaghetti code. Like I said, Python doesn't let us write spaghetti code, really, thankfully. That's why modern programming languages have these structures built in to prevent errors, logical errors, to help us at least try to avoid logical errors. All right. I think that this program is good enough. I think it's well documented enough. Why don't we pause and I make sure no syntax errors for y'all. Are we getting volume here? Have I done the whole lecture without?
I'm not sure.
I hope the whole thing isn't muted. Testing. Testing. I'm alarmed because usually I thought I saw something there. Maybe it only displays that beforehand. Well, I guess I'll find out when the recording's done. All right, so what I'm going to do is I'm going to come up with some pseudocode, and I'm going to want you to try to flowchart it, and I'm going to want you to actually try to write it into Python as well.
Is that the homework or is that?
Yeah, this will be the homework. Okay, it's going to look very similar, but you're not going to just be able to take the same flowchart, delete the text, and add it. It'll be similar though. Okay, so here's what the pseudocode is going to look like. Take this pseudocode and turn it into a flowchart. then turn it into Python. And since we have a holiday, I'm going to double up on the homework. No, I'm kidding. All right. Nobody laughs at my joke. Thank you. All right. So start. We need some declarations. Set min underscore temp equals 0. Set max underscore temp equal to 0. Then we're going to ask the user. We're going to prompt them. Output start table at. I don't want to make these things too long because then when you copy and paste them into a block. Oh, start table at. How about that's enough? Start table at. You know what? We could tell them what in the world we're doing. So output quote temperature conversion table. That's what we're going to be doing. And then start table at, we need some input. Input min underscore temp. Then we need a second output. Output end table at, end quote. Input max underscore temp. Now I'm not doing any error checking on here, so if you type in a minimum temperature of 1,000,000 and a max temperature of 1, it's just not going to print a table. Loop to display table. Don't put that comment in the flowchart. Same thing for up here. Why don't we add a comment, prompt user for input. Whoopsie, but don't put that in the flowchart either. Just because there's no block where you could put it. I guess you could add it as a comment to the side, but we're not gonna. Prompt user for table information. Don't add to flowchart. You understand what I mean by that? It doesn't fit into the logic. It's just a descriptive thing. While the min underscore temp is less than or equal to max underscore temp, print, wait, let's calculate. See, this should have gone up in the declarations because we have another variable we're going to be using. Thank goodness Python doesn't really require declarations, so when I get tired of following book perfect format, I'm stop doing this. Set temp F equals 0, set temp C equals 0, our two temperatures. Now I'm going to change my while loop because I'm going to come down here and add a variable just like we had our counter. So I'm just deleting my while loop. You don't have to. But temp F equals min underscore temp. Temp F equals min underscore temp. Except I should have the word set in front of it since this is pseudocode. While temp F is less than or equal to max underscore temp. Now start indenting. Print, whoops, we haven't calculated the temperature in C, so we're going to have to use a formula to do that. Set temp C equal to 9 or 1.8 times parentheses temp F minus 32. Now these are literals. You could consider these magic numbers, but they're just part of a math formula. I'm not going to go about and declare some constants equal to 1.8 and 32 because I don't think it would make the program any easier to read. And then we're going to print parentheses temp C, comma, temp F. Vice versa. Temp F, comma, whoops, I started going into Python. It's not a print statement. Output, quote, temp C, take that quote off. Temp C, comma, temp F, back tab, end while. And then print output. Whoops, I forgot something important. This is going to be an infinite loop. And it may be that nobody's going to spot why it's an infinite loop. But why would it run forever? I never change the value of temp F, so this is always going to be true. If it's true at all, it stays true. So I'm going to come up here and I'm going to do temp F or set add 1 to temp F. End while, output done. Alright, I think that's close enough to the flowchart that we just did that it won't be too difficult. You already have a good example, and I also think that it's close enough to our code that you'll be able to do the Python version of it. Oh, stop. Forgot the last ingredient. Word stop. Now, I hope I have the logic right because I'm sending y'all home with this. But as soon as you're not watching, I'm going to actually write the program. And if there are any corrections to the logic that need to be made, I will post them in the announcements and modify the homework. But I don't think so. I think I got it. Alrighty, why don't we declare this the end of class? Any questions over it? Nope. Other people are allowed to respond to my questions besides y'all do. I know you're not the only ones. I appreciate people who answer the questions. Don't stop answering the questions, y'all, just because I asked, but other people kick in. I really need to bring cookies and hand them out. All right, make a Dropbox. We'll be done.